Ninja, begin! Are you ready to have your mind blown with an awesome trick I'm going to show you to solve this integral below? You definitely don't want to miss this because you're going to see this problem in the future. So ninja kick that like button and subscribe and let's get started, class. Huh! Can you tell me in the comments below why you can't use the U substitution method for this problem? Okay, you should have realized that the x terms are already in their simplest form. We don't have, for example, sine of 4 of x dx. But what you can do is the integration by parts method. And maybe you have actually tried that and you got stuck because you were wondering, where do I choose u and dv? It's not so clear here. I have a bonus tip for you at the end of the video, so stick around because I can help you figure out for problems like these, how do you know which to choose? Okay, so I'm going to go ahead with u as e to the x, and then du will be e to the x dx after taking the derivative of both sides. This leaves me with dv as sine of x dx, and then v will be negative cosine of x. And in case you don't remember, the formula for integration by parts is uv minus v times the integral of du. Now, I like to be mindful here, and I use extra parentheses because it helps me to make sure that when I distribute all the terms through, that my minuses and pluses are correct. So I'm going to do that. And for this uv term, that's going to leave me with e to the x times negative cosine of x minus, for v, in parentheses, I have negative cosine of x times the integral of e to the x dx, which is my du. When you simplify everything, you'll be left with negative e to the x cosine of x plus the integral of e to the x cosine of x dx. You might be wondering, okay, well, this is no better than where we started because we started with the integral of e to the x sine of x dx, and this one doesn't seem any easier, and I have to agree with you. But the trick here is sometimes instead of giving up or thinking that we're not making progress, the best bet might be to just keep going. And we're going to do just that because I'm going to use integration by parts one more time. I'm going to choose u once again as e to the x. And if I made a mistake and should have chosen the other function, that's okay. The beauty of this is that we're not going for perfection. With integrals, you might have to go back and just simply redo it. But moving on, du is going to be e to the x dx. dv will have cosine of x dx, and then v will simply be sine of x. So when we bring down this negative e to the x cosine of x term, because there's nothing to integrate there, that term is done, we're going to add it to this integral where we plug in our u and v and dv terms, right? So we're going to have e to the x sine of x minus, in parentheses, v, which is sine of x, times the integral of e to the x dx, which is du. And I know I said dv earlier, it's actually du. Now, when you substitute all that in as we did above and simplify everything, you're going to be left with the original problem on the left-hand side of the equation, which is e to the x sine of x dx is integral. It's going to be equaling negative e to the x cosine of x plus e to the x sine of x minus the integral of e to the x sine of x dx. Once again, it seems like we might be going in circles, and maybe you've dealt with that with integration by parts. I know I have, but there's actually a really cool thing you might notice here. I want you to pause the video and think about it. It's borderline illegal, but it's totally legit math because there is a thing you can do here to both sides of the equation, which is a hint to get you to the answer. Okay, you might have already seen what we can do here. And before I actually solve this problem, I know I promised you a bonus tip at the end of the video, but I want to share it now. What you can do for problems like these is when it seems like you're not making progress or both your u and dv functions look like e to the x or sine of x, where regardless of if you take an integral or a derivative, it seems like they go back and forth. Because, e to the x will always be e to the x when you take its derivative or integral. And sine of x will just flip back to cosine and vice versa. What I like to do with problems like these is, A, it gives me a hint that my first go around at integration by parts might not be perfect, and that's okay. Sometimes you go back and you simply choose the other function as u. B, it tells me that more than likely I'm going to have to use integration by parts multiple times. And C, a big hint, is that the solution might, in fact, for a problem like this, be what I'm about to show you here. And maybe you already got this. Leave a comment below if you did. But remember how I told you there was something very special about this equation. Notice how the original problem shows up on the left and right-hand sides. The only difference is on the right-hand side, you have a negative, aka a -1. But then on the left-hand side of the equation for the original function, notice that you have a one constant in front of the integral. And that's cool, right? Because this is an equation. It's funny that this is allowed, but it works. You can add the original integral of e to the x sine of x dx to both sides of the equation. And you will be left with 2 times the original problem on the left. And this is where you can then divide the term through.